all of my examples so far have been indefinite integrals, where we're just solving for a family of antiderivatives. But we can use this technique on definite integrals too. Let's try to solve for the definite integral of t times the cosine of t between 0 and 10. So my solution to this problem should be a real number. Ordinarily, I would say, let's use the fundamental theorem of calculus, find an antiderivative, evaluate at 10, evaluate at 0, and take the difference. What I'm going to do this time is I'm going to use integration by parts to find that antiderivative. So with all of my integration by parts stuff, I need to find a u and I need to find a dv. And this will be equal to u times v minus the integral from 0 to 10 v du, right? I need to keep the very same bounds that I had from before. A technicality with this method is that u times v is going to be part of the antiderivative, so I will need to evaluate those from 0 to 10 as well. Because I know the derivative of t is just going to be 1 dt, my differential of t, excuse me, then I'll say that u is just equal to t. My differential du will be equal to dt. That forces me to conclude that my dv is cosine of t dt. And what is the antiderivative of cosine? Why, that is just the sine function. Now I have all of my reagents. Excuse me. Now I have all of my reagents, so I can put them up into my chemical formula up here. I guess we're doing alchemy today. U times V is T times the sine of T. We put a dot in there because those are multiplied. And again, this is my antiderivative. So I need to evaluate at my upper bound and my lower bound and take the difference, right? This is exactly the same kind of notation I would use for doing fundamental theorem of calculus stuff. Because I am doing the fundamental theorem of calculus and stuff. I also need to have the definite integral of v du from 0 to 10. The bounds are really important to keep track of. V is the sine of t. Du is dt. So I'm subtracting off this integral. What is my antiderivative of the sine function? That is minus the cosine function. And again, I have these bounds. Now I just do my evaluate and subtract. The only thing I need to be really careful about here is what happens to my minus sign. Make sure I distribute that all the way through. So, take t, replace it by 10. I have 10 times the sine of 10 minus, take t, replace it by 0. 0 times the sine of 0. Hey, nice. I then subtract all the stuff in this set of brackets. Take t, replace it by 10. I have minus the cosine of 10. Take t, replace it by 0, and subtract that. So I have minus the cosine of 0. there is my evaluation step. I can simplify. 10 times the sine of 10, I'll just leave that as it is. I am a fan of exact values. And then I have to subtract off 0 times some stuff. And that other stuff is also 0, so I'll just drop that. Here I'm subtracting a bunch of terms in parentheses, so I need to distribute and make sure it is applied to every term in there. So I have minus negative cosine of 10, that's going to be plus cosine of 10. And then I have minus negative cosine of 0. So that's going to be minus cosine of 0. Or if you want, I know that cosine of 0 is equal to 1. But I'm going to leave the rest of these in their exact values. And since I'm doing a definite integral, does this formula describe a real number? Sine evaluated at a number times a real number, cosine evaluated at a real number. Do some algebra. Yeah, that is the description of a real number. So this is the answer that I'm looking for.